Hi, good morning. My name is Sunil, and today we are just going to have a session on Introduction to Java. So we will see what Java is, how to write a program in Java, how to compile it, and how a program after getting compiled is run in Java. And we will see about JRE, JVM, and some OOPS concepts. So many of you have heard about Java. So you know Java is a programming language. There are many other languages in the market today like C, C++, C Sharp, and some scripting languages like PHP and many others. So Java is pure object-oriented programming language. When we say pure, it means it obeys or it follows all the rules or all the concepts of OOPS. So we will see how what are the concepts of OOPS and how Java follows them. So let's begin. We'll see what Java. We'll see Java C, that is Java compiler, and Java command. Then go for JVM. You will understand what is JVM and what's the role of JVM. Then comes the OOPS concept, and then we will see how to download and install Java in your Windows machine, and how to download and install Eclipse in your Windows machine. So Eclipse is an IDE, or there are many other IDEs also, but we prefer Eclipse as many organizations, many companies work on Eclipse. So we will download and see how to install it in our Windows machine. Moving forward, so Java, as I told you, is an object-oriented programming language. Means it follows all the rules that an OOPS concept gives. It has objects, it has classes. So we create the classes and we create the object of those classes to make our work to be done. And secondly, Java is platform independent. Platform independent means the program written on Java in one machine can be run on other machine. With the term machine means the platform, means operating systems. For example, if you write your program in Windows, then you can run your program in Linux or Mac or any other operating system. Similarly, if you write a program in Linux or Unix or any other operating system, that can run on many other operating systems, means all the operating systems. So platform independent means written somewhere and run everywhere. So that is what a platform independent. It does not depend on platform. It is not. It doesn't make us compulsion to write a program for Windows that will run only on Windows. But you write a common program that will run on every other operating system, and that is done using the bytecode or the compiled and the interpreted. So once we write the source code, it is compiled and then it is interpreted by JVM. So we will see it, how does it actually happen. But moving forward, so this is what I was telling, that we have a source code, then it is compiled by Java C. Java C is a Java compiler. It compiles our source code, and this source code is then converted into bytecode. Bytecode is nothing but just, it is a file whose extension is .class. So we call it class file also. Source code, the extension for source code is .java, and when it is compiled by Java compiler, it is converted into .class file, and that class file contains the bytecode. And these bytecodes are platform independent. Means these bytecodes can be carried out to any platform, and in that machine, in that platform, we have a JVM, that is Java Virtual Machine. The JVM interprets these bytecodes and converts into that machine specific code, and our program runs. So these bytecodes can be compiled by JVM and can be run on any machine. And also remember, JVM is platform dependent. When we say platform dependent means JVM for different operating systems are different. For Windows we have Windows JVM, for Linux we have Linux JVM, and similarly for all other operating systems we have their own specific JVM, and we can download it and use it. It's freeware. So as you know, Java is free to download. So for the specific machine, JVM is downloaded and installed. Then doesn't matter which bytecode or which machine's bytecode you are getting. It is just bytecode for the JVM. its job is just to read the bytecode and convert it to that machine specific language. And that is the beauty of Java, that it is platform independent. Moving forward, if we look at this thing, that is Vora. Vora means write once, run everywhere. If you write a program once in any machine, you can run it anywhere and everywhere. So we have a source program, and this source program is compiled and it's converted into class file. And these class files can be given to any specific JVM. It can be Windows JVM, it can be a Linux JVM, it can be Mac JVM. So the same class file, if you give to 3 different or any number of JVMs, the class file will run as a program, because JVM can read the class file or can read the bytecode. As the class file contains the bytecode, it will read the bytecode and converts or interpret them in the machine specific language. That's why we call it write once, run everywhere. If JVM is installed in a machine, so that JVM should be installed for the specific machine in that system. Now let's discuss something about JDK and JRE. So if you have ever got a chance to see the Java installed in your machine, you must have seen there are 2 folders created. One is JDK and another one is JRE. So we will see what are JDK and what are JRE and who needs them. So first come to JDK. JDK is Java Development Kit. It contains tools and needed to develop a Java program. So clearly it says that JDK is required when we want to do some development using Java. Suppose if you want to do some development using Java language, then you have to install JDK. And in case you do not want to do development, but you just want to run the Java application, then you need only JRE. You do not require JDK. So for a developer, for a person who just want to do development, he needs JDK as well as JRE, because JDK will be used to develop and compile the program, whereas JRE will be used to run that compiled program. So JDK is compiler and debugger, because it has to compile and debug our programs that are in Java, whereas JRE contains JVM, that is Java Virtual Machine. We will discuss it. So it contains JVM that contains class libraries and other supporting files to run that compiled program, to run that class file, or to run that bytecode. So if a person or a normal user, or any customer or client, they just have the JRE installed in their machine, whereas a developer have JDK and JRE post installed in their machine, because they have to develop, they have to debug, and they have to compile the source code. And that compiled source code is given to any customer, any client, or any person who just want to use the application. And that person should have JRE installed in their machine, and then it is run. So JRE also contains class loader, which loads the classes for machine code conversion. So as we discussed earlier, bytecode is interpreted into machine specific code. So that is done by the class loader. So we will see what is the class and why it is loaded. So moving forward, this is an JRE environment, or just not environment, just a architecture showing some graphical manner. So we have in class loader there. So it loads the class. What is the class? I will discuss it further slides. So just remember, class is something that runs. So class loader loads the class, and it has a bytecode verifier. As you know, class files contains only the bytecode. So it is necessary that there should be a bytecode verifier to verify whether the incoming bytecodes are correct, are valid, or they are invalid. Means the class loader will load every file that has the extension .class. So suppose if you make any file with the extension .class and try to give it to JRE, it won't run, because the bytecode verifier which verifies and says that this bytecode is invalid. So it will allow only those bytecodes to proceed to JVM which have been compiled through Java compiler and which are valid one. So bytecode verifier verifies the code, and after its verification, if it is found correct, it is sent to JVM, and JVM reads that bytecode and interprets into machine specific language. So that is what we call the JRE, or Java Runtime Environment. We have been talking about JVM, Java Virtual Machine. So there are certain properties what JVM is. So JVM is a interpreter of bytecode. We have already just discussed it. It differs from platform to platform. That is, it is specific to a platform. For Windows, we have Windows JVM. For Linux or Mac or any other operating system, we have their own specific JVM. JIT, that is just in time. JIT means just in time. Compiler is a part of JVM. It helps to compile the selected portion of bytecode into executable ones. Means we have a long program, so just in time will help to select a specific bytecode and to executable ones. So at a time, only one specific portion is executed, and it makes the performance better because now the complete program is loaded into memory and it is compiled, interpreted, but it is interpreted portion by portion. It is done during runtime. So of course, when the program is running, then only it is done, because JVM works only when the program is running. So that's what the intro was about Java. As we know, Java is object-oriented programming language. So let us understand what are the properties of object-oriented programming language and how Java follows them. So there are mainly 4 properties that OOPs have: abstraction, encapsulation, inheritance, and polymorphism. Looking forward to abstraction. Abstraction means hiding the unwanted or the details that are not required. Means all the backend details or the unwanted details are hidden. For example, I'm sorry. For example, if you're driving a car, so you just sit into the car, you just turn your key and your car is started. You just put your car into gear and give the accelerator and the car starts moving. So for you, you did only 3 or 4 actions. That is starting the car, putting the gear, giving the accelerator, and the car moves. But what happened? When you turn the key, what happened inside? There were many things happened. Right? There was a spark. There was some fuel running inside. There was many electricity supply going here and there. So many things happened when you turn the key, but your car started. Then when you put the gear, similarly many other machines inside your car came into picture. Some went here, some went there, something happened, but you were not aware of those. Similarly, when you give accelerator, something extra happened. The fuel supply was more and many other things happened inside that we can understand. But those details were not shown to us. What we saw is we are turning the key, putting the gear, giving the accelerator, and car moves. So we are only seeing the work happening. We do not know what happened inside. And we also do not want to know that, because that is how the system is developed. If we come to know about that, it's very complex. So that is what the property of abstraction says, that hide the unwanted details and just show the work is happening. So that user feels much comfortable and he does not know the complexity. So when there is no complexity, the user feels more comfortable. And the backend data are hidden from the user. How we follow abstraction in Java is we have the abstract classes and interfaces. So we have different sessions for abstract classes and interfaces. Each session we'll discuss in the respective sessions what are abstract classes and what are interfaces. But we follow the abstraction property in Java using our abstract classes and interfaces. Moving forward to encapsulation. So encapsulation feature, or it is a property of keeping the things together. If you look into, break the word encapsulation and look into this encapsulate, or sorry, the capsulate. So what is a capsule? Capsule means when somebody falls sick, they go to doctor and doctor gives them some medicines. Medicine can be in form of liquid, it can be in form of tablets, or it can be in the form of capsule. So capsule is given when the person needs many medicines in a single go. So many medicines are put in their respective proportion or respective ratios into a single unit, that is called capsule, and that capsule is given to the person who eats it and gets better. So capsule means putting many things all together. That is what the property of encapsulation is. Putting all the things that are used to perform a single task are kept in a single unit, and that property is called encapsulation. So binding, in terms of language, in terms of technology, what we can say, binding the code, the data, and many other things in an entity to keep it safe from outside interference, so that outside interference cannot pollute it, cannot interfere it. So we keep it bind together in a single entity, and that is what the property of encapsulation is. So what are the properties that we can have in a language? We can have the code, we can have the data types, we can have the variables, we can have the methods and functions. So all these things are kept together in a single unit that we call the class. So we have the classes in Java that show the property of encapsulation. Now for accessing the classes, we have three properties. It can be private, protected, and public. We will discuss what are these properties means and where do we use it. These are just these properties just make the class as private class, protected class, and public class based on their availability to different user or different other classes. So the property of encapsulation of OOPS is followed by Java using class. Moving forward to polymorphism. Polymorphism simple means poly means many, and morphism means forms. So a single entity or a single person or single thing or anything, just take a single entity, have many forms based on the environment, that is polymorphism. One name, many forms. For example, method is something we call it a function in Java. So wherever you see the word method, it is just a function that does some task. Same method name with different arguments list, same the namespace. So this is in terms of any language. So when we have the method with the same name, but their arguments are different, so it saves your namespace. Means you can use the method as per their argument. So the method name is same, but it has different forms. It has different forms because of different arguments. So it shows different properties. So you can call the same method name in different name, and you will see that their task is different. So that is what the property of polymorphism is. So in Java, we have the polymorphism mechanism or have the polymorphism property by method overloading and method overriding. So these are two concepts in Java that have the polymorphism to be happen. Method overloading is a compile time polymorphism. Compile time polymorphism is when a Java program is compiled. Then it is checked for the polymorphism, and that is method overloading. What is method overloading? What is method overriding? We will discuss in their respective sessions because they need a lot of time, lot of practical to understand them. Method overriding is a runtime polymorphism. It is runtime polymorphism because it happens when the program is run by JRE and JVM. So these two things shows the property of polymorphism in Java. We have sessions on method overloading and method overriding. We will discuss about these properties with the examples there. Just for example, you can see calculate area method name, calculate area, method name. So method names are same, but the first method is 1 parameter, other method is 2 parameters. So when we call the method, we will call only the calculate area based on the number of parameters. The calculate area for a square or the rectangle will be called. So we will see it in discuss, but this is just for your reference or for your just for example now. Moving to the last property of OOPS, that is inheritance. Inheritance means getting the parents' property. Like you are a son or you are a daughter of your parents, so you must have got some properties from your father and mother. In short, you must have got some properties from your parents. Similarly, your parents must have got some property from their parents. So it is coming from one level to other, to other, to other. Means it's a kind of inheritance from your parent to child. That is what a polymorphism is, and that is what all the living things in the earth, in the world, so is polymorphism. Even I have got some properties from my parents. Everyone have got some properties from their parents. So in Java or in OOPS, what we say is, suppose B is a class and A is inherited from B. So whatever properties, so in terms of technology, what kind of properties? The properties can be methods, functions, and variables. So whatever properties B has got can be used by A. A will have his own properties, his own methods and variables, but along with that he will have the properties of B as well. So that is the kind of inheritance. A is inherited from B. Taking a step forward, suppose B is inherited from C and A is inherited from B. So since B is inherited from C, B will have the properties, B will have the method or the functions or the variables what C has, and since A is inherited from B, so A will also have all the properties of B. Since B have the property of C, so A will have the properties of C as well. So A will have the property of B and C both. Similarly, if there would have been one more class here and that is inherited from A, then that class would have the properties of all the 3 child classes. So these are called child classes and the upper one is called a parent class. So that is what the inheritance is, and this type of inheritance is called simple inheritance because it is only one level, whereas this is a multi-level inheritance. So we have the property of inheritance in Java and we do it using the keyword extend. So we will discuss is how do we extend a class to another class and how do we get the properties of one class to another class, and this is how we fulfill the inheritance concept of OOPS into our Java applications. So these all were the OOPS concept: abstraction, hiding the unwanted details, encapsulating, putting the things in single entity, inheritance, getting the property from one class to another class, polymorphism, having more than one form with the same name. All these properties, all these OOPS concepts are fulfilled by Java, and that is why we call Java as a pure object-oriented programming language. Moving forward, download and install Java. So Java is free of license, means anyone can download it, anyone can use it. There is no license required. This is the link to download the Java. If you click on this link, you will be taken to a website that is of the Oracle. From there you can download a JDK or JRE based on your requirement and you can install it. If you want to do development, download JDK. So once you download JDK, both JDK and JRE will be installed, and if you download only JRE will be installed in your machine. It is freeware. You can search download Java in Google and you can get the link from there. You can actually go to oracle.com and from there you can download Java because Java is part of Oracle. Once you download and install Java, we need some IDE to run the to develop the application on Java, to compile it and to run it. So the IDE that we are using and that the most organizations and that is very popular in Eclipse. So you can download the Eclipse IDE and you can install it. So once you download and install it, you are done with your IDE in Java. You can directly go into the development procedure. So what we saw is what is Java, what is JDK, what is JRE, what is JVM, and the OOPS concept. So let us see how does a Java looks like, how does a Java program works, how it is compiled, and how it is run, and also we will see what is Eclipse, how it looks like, and how we put some development in Java. So beginning from the Java, let us see how a code is written in Java and how it is compiled. So for time being, the Java is by default installed in program files in Java folder. So in your C drive, this is the default location. You can change as per need also, but if you do not change the location, it will be installed in the program files in Java folder. So here you will see there are a JDK folder and there is JRE folder 6 and JRE folder 7. So 6 and 7 are stored the version of Java or JRE. So this is JDK because I am going to do some development in JDK in Java, so I have to help JDK. There are certain supporting libraries, supporting files that have the capability for compiling and debugging the code. So for initially we have to do the development in any text editor. For example, here I am using the Notepad, or you can use any text editor, but Notepad is available everywhere, so we have the Notepad. I will write a code in Java that may not be much familiar to you, and you may not understand all the things, why this, why that. We will discuss them clearly, then we will go into actual programming, but here we just want to see how a Java works. So we create a class. Let's say the name should be Hello Java. So this is the class name, Hello Java, and this is how a class begins and this is how a class ends. So a class contains variables and functions, that is methods. So we can define variables and methods inside of this single entity, a kind of encapsulation in this class. So we should have a main method. So public static void main and some arguments and this is how the method begins and whatever we want to write, we can write into it. So here we can write anything that we want to do. For example, system.out.println. This may not be much familiar to you. We will discuss it in our further sessions. This is my first Java program and semicolon. So just for now you can understand this is the main method and these are the arguments to the main method, and this is a public that is, it can be accessed from everywhere. This is the void, the return type of the method, and this is some keyword static that does some specific job. So for now just understand this is the main method and this is what we are doing inside this method. Here we are just printing it. This is my first application or this first Java program, and we are closing the method, we are closing the class. So for saving this, we have to save it inside JDK and bin folder. So for running, you have to always, for your means you can save it anywhere, but it is advised to save in a bin folder so that you do not have to match all the things. So the file name should be the same what the class name is, and Java is case sensitive. So take care of the words. So hello and Java is capital, and the extension, as I told you initially, for source file it is Java. So hello java.java, and we go for save it. So if you go into the bin folder, you will see there is a Java file, source file, hello java.java. So it is there. Now I want to compile this file, and after compilation I know it will be converted into .class file. Let me see. So for compiling, we use the command window where we can call the Java-C program, and this is what Java-C program is. So we will call this command to compile our hello Java. Let us see. First I have to go to this location cd and cd. There I am. So in bin folder I have the hello Java. So for compiling I need to call Java C, that is this one, Java C, and the class file hello java.java. So if there will be no error, this will be compiled and you will not get any message, but you will come to the next line. Yes, so there is no error and we came to the next line and you will see a class file has been created here, hello Java, and there is no hello class file. So this class file has the bytecodes. So this bytecode are used by the JVM to run it. So to run the bytecode, to call the JVM, we have the command Java and the class file hello Java. We will not give the extension. Hello Java is sufficient. So we are calling the JVM by the Java command and give the class name to run. When I enter it, I get the output. This is my first Java program. Sorry. So you see we have the source file, we call the compiler, we got it compiled, we got the class file, and we call the JVM using Java command, and when we run it, we got the output. So this is the structure, how does a Java program run and how a Java actually works. The same thing can be done in Eclipse as well. In Eclipse, we need not go to this location. We have no hard and fast rule to call Java C, Java. Everything is done by the Eclipse itself. We have to just do a single click. And this is how your Eclipse looks like. So once you open your Eclipse, you will see this window. Currently, it has all the list of applications, list of programs, projects you have created. Right now, I have not done anything, and it has got certain buttons over there. Once we go into details, we will use each and every button based on our requirement. For now, we have to run a simple program, so we have to create a Java project. There are many other things we can create: project, package, class, interface. We will see all those things. But first, we have to create a project where we can keep our source file and we can compile and run it. Let the name of the project be my project. Here I can choose which version of Java I want to use. I can use any version, but let me use 7. And click on next. Everything is okay. Click finish. So you will see my project. A project has been created. It has a list of libraries that are used to compile and run your program, and it has a source folder. This source folder will contain your source class, source code. So to write a new source code, we write it in a class, so we will create a new class. Let me give it a name as my class, and we should have a public static void method here to run it. So I will tick mark this method so that this method is created automatically. I need not type it, and click on finish. You will see class, my class, and it has open braces, it has a closed braces for that, and it has the same method, public static void main. It is open and it is closed, and inside it we can type whatever we want to write it. So let me type the same thing. That is, if you see this code, I had to write whole thing myself. I have to type everything, but here we have the shortcuts. We can type just this out and out space. It is done automatically. So it makes the work easier, and then we can type anything. Hello user, I am Java program. So this is what I am printing. So my class is ready to compile and to run. I need not call the Java C or Java to call or compile or to run it, but instead I have a button here that is run. When I click on run button, this program will get compiled and you will get the output as well. So here you do not see any error mark. Suppose if you have any error in the program, for example, I have deleted it, there I can get an error. So it shows you the error immediately, and it gives some options also to correct it. So it is giving something, syntax error, insert semicolon. So it is telling me please insert semicolon here. So Eclipse makes your job much simpler, much easier. You really enjoy it doing the job, and it is fast. So my program is ready to compile and run. Let me click on run button. So as soon as I click on run button, it is asking me which class you want to run. I want to run my class. Okay. There I got the output. Hello user, I am Java program. So you see, I was not going to compile using Java C or run using Java, but just type anything, click on run button. For example, if I make any further changes in it, first instance I want to print numbers from 1 to 10. So if you are familiar with for loop, then it's okay. Otherwise, for now, just see it. Or int I equal to 0, I is less than equal to 10, I plus plus, and says out I. This is written. I have to just run my class. There is the output. So this is the first system.out.println, and this is the further the output numbers from 0 to 10. So you see, writing the program in Eclipse is much easier. What is happening here is just the same thing what happened here. Saving the program as Java. You can see this is saving as Java. Then compiling it and running it. So Eclipse takes care of compiling and running automatically. You need not compile and run separately, but you just type the code, save it, click on run, and that is what it is done. So this was just a demo session on Java, an introduction to Java. We studied about Java, JVM, JRE. We studied about the OOPS concept. We saw that we can download the Java and install it. It's freeware. Similarly, we can download and install Eclipse. It is also free. Need not take any license for that. Anyone can use it. Then we saw how to write a program in simple Notepad, how to compile it and run it in Notepad or any editor. Then we saw the same thing about our the same thing in using Eclipse, and we saw it is much easier and doing the same thing in Eclipse. So that's what we studied today. So there are certain skills. Java is platform independent. Yes, we know it. Java is platform independent. Sorry, JVM is platform independent. No, JVM is not platform independent. JVM varies from platform to platform. What type of inheritance does Java support? It supports simple and multi-level. Then we saw A to B and B to C, C to A. We saw those things. So that's what we have in today's session. In next session, we will discuss about data types. We will discuss what data types are, what variables are, how to define a data type to a variables, and what type of data it can show. So we will go into details of that. Thank you for your time. Thanks for seeing my slide. Bye. Take care.